This video presents a brief introduction to shallow foundations and the strategies to solve the questions in the handout. A shallow foundation transfers the loads of superstructure to the earth very near the ground surface. There are three types of commonly used shallow foundations, including raft foundation, which is a flat concrete slab that covers the entire area of soil under the structure so that to lower the contact pressure. It is usually intended for low-strength soils. Strip footing, which serves to spread the load of a wall across an area of soil. And square footing, which supports the load of columns. The hazard related to shallow foundation comes out of two sources. That is the bearing capacity failure and unequal settlement. The bearing capacity failure consists of three modes: general shear, local shear, and a punching shear failure. The photo to the right shows an example of costly failure of shallow foundation. Unequal settlement of the shallow foundations also causes a serious problem to the superstructure: inclination, cracks, and even collapse. Then what should we consider and handle in the design of shallow foundations? Both objective and subjective uncertainties hide in the corner. The objective uncertainty comes from variation in loads and resistances, inherent variability in ground conditions, inaccuracies in design model equations. These uncertainties are handled by factor of safety, experiences, and judgment. The subjective uncertainties comes from gross errors, human errors, omissions, and construction errors. These uncertainties are handled by QA/QC programs. Notably, the factor of safety is not expected to be responsible for subjective uncertainties. In the study of a CV481, we only focus on the objective uncertainties. There are two design approaches, including working stress design since 1800. In this design method, a global factor of safety accounts for all uncertainties of loads and resistances. And a limit state design, which has been progressively adopted in the past decades. This approach recognizes and considers that different degrees of uncertainties exist for each of the various loads, strengths, and resistances. As we can see from this equation, the resistance is factored by phi, and a variety of loads, S and I, are factored by different factors, alpha I.